So yeah, awesome. Let's get a little bit of practice with these optimizations. Like an example should make it clear, like, how exactly do this work, or like what are the edge cases, blah, blah, blah. We'll go through this here. So this is problem 4B on your handout. Feel free to take a look at this. If you want to pause the video, try it out on your own, come back to this afterwards and watch me go through the solution. That would be great, I think. Yeah, it's always good to like try something out on your own first to make sure that you, like, if there is like a misconception that you have, like that you iron it out. But anyway, I digress. I will start going through the solution now. So totally fine if you just want to follow along and watch what I'm going to do. So we start off with a disjoint set that consists of these kind of 4 little mini sets here. One with size 6, size 1, size 5, size 2. So we always kind of keep track of the size and also the elements in that disjoint set. Sorry, 1 second. I'm going to take a sip of water. Okay, so our first operation that we have is union of 2 and 13. So remember, for the union, we always connect the representatives. So what we're going to do is we're going to look, we're going to call like find set on 2 and 13 because we need to like get their representatives, and find set is the thing that gives us the representative. So I'm going to call find set of 2. That's going to give me, whoops, I went through the solution. Find set of 2 is going to give me this right here because 2 is already its representative. I can't go up and look for another representative. I call find set of 13, and that's 7, right? Because I'm going to keep going up. And then I see, okay, so I have the representatives, which are 2 and 7. Remember too, when I did that find set call, I'm going to do this path compression, but there's actually nothing to compress here because 2 is already the root and 13 is already pointing to the 7, right? It's already pointing to that root. So we don't really do any path compression here because, we don't do any path compression here because there's, like the nodes are already pointing to the root or they are the root itself. So now what we do is we're going to do that second optimization. You could say, well, we're going to connect the representatives to each other. Should I connect the 7 to the 2 or should I connect the 2 to the 7? The answer is that I should connect the 2 to the 7 because the 2 is the smaller sized set, right? Remember that optimization 1 says that you connect the smaller size to the larger size. So this is what we do. Connect it like that. Then this is our state. And we're done with the union. And we leave it like this. And we go on now to union of 4 and 12. So we're going to repeat that process. I'm going to call find set on 4. And that's going to say, okay, so start at 4 and traverse up. So I see 4, traverse up to see 6. So I get 6 is the first representative. The second thing for 12, I'm going to call find set of 12. I see 12, 11, 8. So, we called find set on 12, we called find set on 4. We get these representatives, these purple things. But remember, right, we actually did call find set here, so we have to do some path compression. We're going to point this 12 now at the 8, right? Because remember, path compression says that everything along that path is going to point to the representative. So we path compress, point 12 to the 8, and yeah. We haven't actually done the union yet, but this is just like after the first find sets, right? Because I did call find set on 4, and I called find set on 12. So, in the find set, you're going to do that path compression. Notice here, though, that we're not pointing the 5 up to the 6, even though the 5 is sort of like on this path. The reason is that like when we start at 4, we don't look at any of our children or anything like that, right? Like, remember, there's like no way to get my children at 4, right? I can't go down, I can only go up. Right, so I actually have no idea who's pointing at me if I'm the 4 node. So I don't worry about anything pointing at me. I only worry about things that I'm pointing to, or like things along the path up to the root. So I'm not actually going to path compress this 5 because I didn't see it in that call for find set of 4. Okay, cool. After we do the path compression, though, we should check. Okay, I've got this set and this set. Which one should I connect to the other? Well, I connect the lower size set to the larger size set. So I'm going to draw the arrow from the lower size set to the larger size set. And then we're done with that union. This should be the result of our disjoint set after that. The tricky part of that was that we did do a union, but implicitly when we did that union, there is a path compression that happens. So that's like a tricky thing that you'll have to make sure to, get right on these problems. Cool. Okay, finally, union of 2 and 8. Okay, I'm going to look for 2, it's connected to the 7. Looking for 8, connected to the 6. Again, no path compression here, right? Because, again, I'm not looking at my children if I'm 8, right? I don't know what my children are. I don't know what's pointing to me. So I only worry about things along the path up. So no path compression to do. Should I connect the 7 to the 6 or the 6 to the 7? I'm going to connect the 7 to the 6 because this set size is smaller. So then we get this. Now we're done. So that was the result of those 3 union calls. And yeah, that was the problem. If you have other questions about this, feel free to post on Piazza. We'd be happy to answer them. But otherwise, good luck.